Hey everybody, Mr. Walker. In this lesson today, we're going to cover some trig applications. The last few days, you've been learning about right triangle trigonometry using sine, cosine, and tangent to find missing sides and missing angles. Today, we're going to extend those concepts to solve some application problems or to solve some word problems. But before we get actually started solving the word problems, I do want to discuss new terminology. We have the angle of elevation and the angle of depression. You will encounter these terms when you are working the word problems. I do want to ensure that you know what they mean. So I have a picture right here, and angle of elevation goes from the hold on one second. Let's see if I can get this to work. So the angle of elevation goes from the horizontal up. So here we have a person. At first, they're looking straight ahead. That's the horizontal. Then an airplane flies overhead, and they look up at the airplane. So the angle of elevation is that angle that goes from the horizontal up to the new line of sight. So remember, the angle of elevation goes up from the horizontal. Angle of depression goes down from the horizontal. So again, the person's first looking straight ahead, that's the horizontal. Then they look down at a dog. The angle of depression is that angle that goes down from the horizontal to the new line of sight. That's the angle of depression. Let's say, I'm going to give you another example of the angle of elevation. Let's say we had a wall. Here's the ground. And we have a ladder. This is a ladder leaning against the wall. The angle of elevation, again, goes from the horizontal, which in this case will be the ground. It goes up from this horizontal to the ladder. Okay, the angle of elevation goes up from the horizontal, in this case, to the object, which is the ladder. So the angle of elevation is that angle right there. That's the angle of elevation. Now, the angle of depression, when we're talking about this ladder that's leaning against the wall, is a little bit more difficult. A lot of people think that this right here is the angle of depression, because it is an angle that's going down, but that is not the angle of depression. The angle of depression, I'm going to go ahead and draw it in here. Remember I said the angle of depression always goes down from the horizontal? Well, I'm going to draw in the horizontal. Okay? I start at the top of the ladder, and I draw a straight line going out from the top of the ladder. The angle of depression goes from the horizontal down to the object. So this right here is the angle of depression. This is the angle of depression. Okay? Now, when we start working problems, there's one extra step we have to take. We have an angle of depression. And I will tell you how to work that when we actually start doing some of those problems. We will do angle of depression in the last two problems. But right now, let's go ahead and get started with the word problems. And we will see those terms coming up again, angle of elevation and angle of depression. So our first word problem's right here, and I'll go ahead and read through it real quick. A 20-foot ladder leans against a wall so that the base of the ladder is 8 feet from the base of the building. What is the ladder's angle of elevation? So the first thing you do when you're working these word problems is you have to draw a picture. Absolutely have to. It's not optional. And the reason you have to draw a picture is because you have to find the triangle. The problems that you are working on Monday and Tuesday, the triangle was given to you. You just had a triangle, they labeled the sides, they labeled the angles, and then you just find the missing side or the missing angle. Well, here, all we have is words. So before we can even start solving it, we have to have that triangle. Well, in the process of drawing the picture, you will find the triangle. Once you find the triangle, it's going to become exactly like the problems you were working on Monday and Tuesday. So we're going to go ahead and draw this, and we're going to take it word by word, sentence by sentence. So we have a 20-foot ladder leaning against the wall. So that's the first thing I'm going to draw. I'm going to draw a wall. Well, I'll try to. It's a little crooked, isn't it? Draw a wall right there. Now I have the ground down here. And we have a 20-foot ladder leaning against the wall. So I'll go ahead and draw this ladder. And it tells me it's 20-foot ladder. So I'll go ahead and put a 20 right here. That tells me that this ladder is 20 feet long. Let's see what else we have here. So that the base of the ladder is 8 feet from the base of the building. Well, base means the bottom. So the base of the ladder is 8 feet away from the base of the building. So this right here, that is 8 feet. So I'll go ahead and label that 8 feet. What is the ladder's angle of elevation? Well, we just talked about angle of elevation. Angle of elevation, again, it goes from the horizontal, which in this case is the ground, the horizontal, and it goes up to the object. So the angle of elevation is that angle right there. It goes from the horizontal, which in this case is the ground, up to the object, which is the ladder. That is the angle of elevation. So I'll go ahead and put my little arc mark. An arc mark is this little symbol right there. Tells me that's the angle I'm working from. And there we have it. Now we have a triangle. Once we find our triangle, it becomes like the problems you were doing on Monday and Tuesday. So we're going to apply those concepts that you were using in solving those problems to solve this problem right here. And I should also label this angle right here. This is a right angle that makes that perfect L shape, and that's the symbol for a right angle. Okay? So now we need to solve for this angle right here. And this is the angle we're working from. So your first step, always, when you're solving these types of problems, is to label your sides. Okay, you got to label your sides. I always start by labeling my opposite side. So I'm working from this angle. I go straight across. This is my opposite side. So I'm going to label that as O for opposite. Or I'll go ahead and put OPP. That's my opposite side. And then label your hypotenuse. Your hypotenuse is straight across from your right angle. So here's my right angle. I go straight across from my right angle. This side right here is my hypotenuse. I'm going to go ahead and label that hypotenuse, HYP, kind of shorten it up a little bit. And finally, the adjacent side, well, that's the only side we haven't labeled. So this side right here is the adjacent. Okay. And now I'm going to go ahead and write SOHCAHTOA. I'm going to write that up here. And I'll tell you what this means. SOHCAHTOA. SOHCAHTOA is a mnemonic that helps you remember sine, cosine, and tangent. S stands for sine. Sine is the opposite divided by the hypotenuse. C is cosine. cosine is the adjacent divided by your hypotenuse. T is tangent, and tangent is your opposite divided by your adjacent. So we got to determine which one am I using. Am I using sine, cosine, or tangent? So let's look at our triangle and determine which one we're going to use. Well, I'm looking for the angle, and I have two sides. These two sides right here, 20 and 8. Okay, I know the measurement of these two sides, 20 and 8. Well, those two sides are the hypotenuse and the adjacent. So I need to use the one that has A and H. So if I look right here, this is OH, so that's not it. This is OA, so that's not it. But this one right here, AH. That's the one I want to use because those are the two sides I need to use because they have the measurements, 8 and 20, which are A and H. So I'm going to use cosine, okay? I'm going to use cosine. I'm going to go, I'll do the work right down. I'll do the work right here. Cosine and my angle, well, I don't know the angle measurement. Remember, after cosine, sine, or tangent, I have to put my angle. Well, I don't know what the angle is, so I'm going to call it x. So cosine of my angle equals, remember cosine equals A over H. So cosine equals the adjacent, which is 8, divided by your hypotenuse, which is 20. Okay, cosine x equals 8 over 20. Well, I need to find the x. I need to find my angle, which is x. So I need to get this x all by itself, which means I got to get rid of this cosine. And the way you get rid of the cosine is to do the inverse cosine. So let me show you how that looks. Inverse cosine looks like this. Cosine -1. That's a little exponent. Cosine -1, that's inverse cosine. I'm going to go cosine -1 of cosine x. What I do to one side, I have to do to the other side. So I'm also going to take the inverse cosine of 8 over 20. Okay? So just kind of recap, I had to get rid of the cosine. The opposite of cosine is inverse cosine. What I do to one side, I have to do to the other side. Now I said inverse cosine is the opposite of cosine, so they cancel out. So on this side, I just have my, sorry about that. On this side, I'm just left with my x. I'm just left with the x because inverse cancels out the cosine. And on the other side, well, this is what I have to type into my calculator. So I'm going to use Desmos. Let me pull it up real quick. When you're using Desmos, first thing you should do before you start typing in cosine, sine, or tangent is go up to this little wrench in the top right-hand corner. You'll see a little tool. It looks like a wrench. You can go ahead and click on it. There's that wrench. And you see at the very bottom of that pop-up window, it says radians and degrees. You need to make sure that degrees is selected. Okay, it defaults to radians, but you have to change it to degrees. If you don't change it to degrees, you will get the wrong answer for every single problem. Okay, so make sure that it's changed to degrees. You only have to do it once. You don't have to do it every problem, but you have to do it once when you open the calculator. Once you change that to degrees, all you do is type in this right here. That will give us our answer, so I'm going to go ahead and type that in. Cosine -1, that's going to be under the functions. So on your keyboard, that pops up in Desmos. If you don't see the keyboard, just select the keyboard icon and that keyboard will pop up. You got to select functions on the keyboard. There's a key that says functions. I'm going to go ahead and push that. And I get all these functions. Trig at the top is the one you need to be under. You have trig, stats, dist, and misc. You need to make sure that trig is selected. You'll see these options right here. And I'm going to go ahead and select cosine -1. And then I have my fraction that I need to put in, 8/20. So I put 8 divided by 20. That's not even going there. Hold on one second. 8 divided by 20. Okay. And once I type that in there, I get my answer. It is 66.42. I'll go to 2 decimal places. So my answer is going to be, let me switch to my pen, 66.42 feet. That's going to be my answer. I'm sorry, that's not feet. We were looking for the angle. That's my fault right there. So that angle is 66.42 degrees. I forgot we were looking at angle. Okay, so that gives us my angle. The angle is going to be 66.42 degrees. Okay, so that's that first problem. We're going to go ahead and move on to the second problem, following the same steps. Remember, first step, read through the problem, kind of get a feel for what that problem is asking for. So on the second one, we have, at a point on the ground, 50 feet from the foot of a tree, the angle of elevation to the top of the tree is 53 degrees. Find the height of the tree. So I'm going to go ahead. Once you read the problem, next step is to draw the picture. Got to draw the picture. And just take it sentence by sentence. At a point on the ground, 50 feet from the foot of a tree. So I'm going to go ahead and draw the ground. I'm going to go ahead and draw a tree. And draw a tree. And it says, at a point on the ground 50 feet from the foot of a tree. So I'm going to draw a point 50 feet. There's my point from the foot of a tree. Foot of the tree means the bottom of the tree. So that point is 50 feet away from the bottom of the tree. So that distance right there is 50 feet. I'm going to go ahead and label that. That distance is 50. This distance right here is 50 feet. Okay. The angle of elevation to the top of the tree is 53 degrees. So remember, the angle of elevation goes from the horizontal up. Okay. Angle of elevation goes from the horizontal, which in this case is the ground, and it goes up. And it says angle of elevation to the top of the tree. So here's what that means. I draw a line going to the top of the tree, and the angle of elevation is that angle that goes from the horizontal up to this new line of sight that goes to the top of the tree. Okay? So this is your angle of elevation. And they tell me what the angle of elevation is in this problem. Angle of elevation is 53 degrees. So I will label that 53 degrees. Okay? So there's our triangle. Remember, that's the whole purpose of drawing the word problem, is to find the triangle. Because once you find the triangle, it's just like the problems you did on Monday and Tuesday. So our triangle is right here. Other side of the triangle is basically the tree. It's this right here. So that's my triangle. And now, once we have a triangle, you need to label your sides. Okay, so you need to label your sides. We're working from this angle. The side straight across from that angle is the opposite. So this side right here is the opposite side. So I'm going to label that as OPP. That's my opposite. Remember, I have a right triangle here. A right triangle makes that perfect L shape. The side directly across from the right angle, I'm sorry, that's a right angle. The side directly across from the right angle, this side right here, is the hypotenuse. I'll go ahead and label that HYP. And the side we have not yet labeled is your adjacent. So it's this side right here we haven't labeled. That's going to be your adjacent. Always leave it to last because people have a hard time finding it. Opposite, that's just straight across from the angle you're working from. Hypotenuse, straight across from the right angle. Adjacent's what's left. Then what you want to do, you want to write SOHCAHTOA. SOHCAHTOA. Kind of help you remember what sine, cosine, and tangent are, like I discussed in the last problem. And then we need to figure out which one we're going to use to solve this problem. Are we going to use sine, are we going to use cosine, or are we going to use tangent? So let's look at what we have here. We're working from this angle. I have this side. They give me the measurement of this side, so I have to use this, adjacent. I have to use the adjacent because I do have that measurement. I am looking for, what am I looking for? I'm looking for the height of the tree. Well, the height of the tree is this side right here. And this is opposite. So I have to use the adjacent because that's the measurement I'm given. And I have to use opposite because that's what I'm trying to find. I'm trying to find the height of the tree. So I go up to my SOHCAHTOA and I look for the one that uses O for opposite and A for adjacent. And there it is, OA. Opposite, adjacent, I have to use tangent. Okay? So I'm going to write that out. I'm going to do tangent. Remember, after sine, cosine, or tangent, you always have the angle. So it's going to be tangent 53 equals, well, tangent equals the opposite. Opposite, well, I don't know what the opposite is. That's what I'm looking for. I'm looking for the height of the tree. So I'm going to call it X. We don't know what it is. That's what we're looking for. So tangent equals the opposite divided by the adjacent. Well, here's the adjacent, and the adjacent's 50 feet. So it's going to be X divided by 50. Okay? And now I need to solve that equation. So I need to get this X all by itself, which means I need to get rid of this 50. Got to get rid of that 50. Well, here I'm dividing by 50. Okay, I'm dividing by 50. I need to do the opposite of that. The opposite of dividing by 50 is multiplying by 50. So I'm going to multiply this side by 50. I'm going to, of course, what you do to one side, you have to do the other side. So on the other side, I'm going to multiply that by 50. On this side right here, these cancel out because you have 50 divided by 50. They cancel out, leaving just the X. So this side, I have X. And on this side, this is what I got to plug into the calculator. 50, I'm going to put in parentheses. That just means multiply. Tan 53. So that's what I need to type into my calculator to get my answer. I'm going to go ahead and pull up Desmos again. Now this time I don't have to check that wrench because, like I said, you only have to do it once to make sure it's on degrees. I'm going to go ahead and type that in there. Let's see what it was. 50, parentheses, go to my functions, find tangent, 53, and parentheses. So we have what? 66.35. And that will be your answer. I'll round it off at 2 decimal places. So my answer is going to be 66.35 feet. That's how high the tree is. That's how tall the tree is. 66.35 feet. Okay, that's our second problem. And go ahead and move on to the third problem. First step, again, read the problem, kind of get an idea of what it's asking for. Richard is flying a kite. Kite has an angle of elevation of 57 degrees. If Richard is standing 100 feet from the point on the ground directly below the kite, find the length of the kite string. So first step, read the problem. Second step, draw your picture. We're going to take it sentence by sentence. Richard is flying a kite. So I'm going to draw somebody flying a kite. Here's the ground. Let's see what we got here. We have somebody, sorry about that. Somebody who is, that's the string, flying a kite. Okay, so there's Richard flying a kite. The kite string has an angle of elevation of 57 degrees. So that angle of elevation goes from the horizontal, which in this case is the ground, up, in this case, to the string of the kite. So that's the angle of elevation. It goes from the horizontal up to the kite string. So I'll go ahead and label that. Angle of elevation is this angle right here, and it is 57 degrees. If Richard is standing 100 feet from the point on the ground directly below the kite. So it says a point on the ground directly below the kite. Well, directly below the kite is right here. So that is the point on the ground directly below the kite. Point on the ground directly below the kite. And Richard is 100 feet away from that point. So this distance right here from Richard to this point is 100 feet. Find the length of the kite string. So we have to find this. We got to find, I'll call it X. We got to find the length of the kite string. This right here. Okay, so there's our triangle. Our triangle's right there. I'll go ahead and complete the triangle by drawing this side right here. From the kite down to the point on the ground directly below the kite. But that's our triangle that we're going to be working with. And we need to find the length of that kite string. So next step, I always recommend that you do this. Go ahead and write ka, toa, to remind you what sine, cosine, and tangent are. Okay? And we also need to label the sides of the triangle. So I'm working from this angle, directly across from that side, from that angle rather, is this side right here. Directly across from that angle is this side. That's your opposite. So I will label it OPP. This is my right angle. It's that angle that forms a perfect L shape. And directly across from my right angle, this side right here, that's my hypotenuse. I'll go ahead and label it HYP. And the only side we haven't labeled has to be the adjacent. So this is the adjacent. And now I've got to determine what am I going to be using. Am I going to be using the sine, the cosine, or the tangent. Okay, so let's see what we have here. We have this measurement, 100. This side is 100, so I have to use that. I have to use the side that has a measurement. So I have to use the adjacent. I'm looking for this side. This is the length of the kite string. That is the hypotenuse. So I have to use the adjacent and the hypotenuse. I have to use A and H. So I'll go up to SOHCAHTOA, and I'll look at which one's using A and H. Well, sine uses O and H, so I'm not using that. Tangent uses O and A, so I'm not using that. But cosine uses A and H, so I'm using cosine. Okay? So I'm going to go ahead and write my equation over here. Cosine, always following cosine, is our angle, which in this case is 57 degrees. So cosine 57 equals, and remember cosine equals adjacent, the A, which means adjacent, and our adjacent is 100. Adjacent divided by, and it's divided by the hypotenuse. Cosine is A divided by H. Our hypotenuse, well, we don't know what it is. That's what we're looking for. So we'll call that X. 100 divided by X. And this is what we have to solve. So I have to get this X all by itself. You could go through the entire algebraic process. You can multiply this side by X, multiply this side by X, and then divide this side by cosine 57, and divide this side by cosine 57. But there is a shortcut. You don't have to go through all those steps. Whenever you have X in the bottom of your fraction, X is in the bottom of the fraction, you can take the X and put it over here, and you can take this cosine 57 and put it down here. So these two things can switch places, and it will look like this when I do that. The X will come up to where the cosine 57 is, and the cosine 57 will go down to where the X is. So X and cosine 57, they just switch places. Okay, and now look, X is all by itself. That is ready to plug into the calculator. So I'm going to go ahead and pull up my calculator. I already know it's in degrees, so I don't have to check that. I'm going to go ahead and type in my problem. 100 divided by 100 divided by cosine 57. So I hit functions, I find my cosine 57. And we have 183.607. So that is the length of my kite string, 183.607 feet. I'm going to go ahead and write that down. Let me switch my pen. 183.6. I'm going to go ahead and round it to 2 decimal places. So that 0 will be bumped up to a 1 because the number after it's 5 or higher. So 183.61 feet. That's how long my kite string is. Okay. And that seems reasonable for a kite string. So always make sure that the answers you get are reasonable. For instance, if I got like 5 feet there, that's probably not the answer, because, you know, a kite string's probably going to be longer than 5 feet. Or if I got like several thousand feet, you probably know that's wrong too, because kite string probably not going to go out that far. But 183.61 feet, that seems reasonable. That is the length of my kite string. Okay, that's that problem right there. Here's our next problem. First step, go ahead and read through it real quick. A 50-meter vertical tower is braced with a cable secured at the top of the tower and tied 30 meters from the base. what is the angle of depression from the top of the tower to the point on the ground where the cable is tied? Okay, first step, read through the problem. Second step, draw the picture. So we will draw this picture step by step. A 50-meter vertical tower is braced with a cable secured at the top of the tower and tied 30 meters from the base. So we have a vertical tower. That's the first thing I'm going to draw. What does a tower look like? Tower. I'll draw a water tower. So that's my tower. It's like a water tower, if you've ever seen a water tower. 50-meter vertical tower. So this tower is 50 meters tall. And it is braced with a cable secured at the top of the tower. So the cable goes from the top of the tower, tied 30 meters from the base. The base means the bottom of the tower. So I have a cable going from the top of the tower to the ground. So we have a 50-meter vertical tower braced with a cable secured at the top of the tower and tied 30 meters from the base of the tower. So this is 30 meters from the base of the tower. So that distance right there is 30. What is the angle of depression from the top of the tower to the point on the ground where the cable is tied? Okay, what is the angle of depression from the top of the tower to the point on the ground where the cable is tied? You know, I don't like how that's worded necessarily. They want the angle of depression, okay? So on this problem right here, what is the angle of depression? From the top of the tower, I'm going to change this from the top of the tower, cross that out. From the top of the tower, I'm going to change that to the cable. Make it a little bit more clear what they're asking about. I didn't like the way that was worded. So what is the angle of depression from the top of the tower to the cable? Well, the angle of depression is that angle that goes from the horizontal down. So we got to start from the top of the tower, angle of depression from the top of the tower. Well, here's the top of the tower. First thing I got to do is I got to draw my horizontal line. So this is my horizontal line right here. Okay. And I got to find this angle of depression right here. Okay, because the angle of depression goes from that horizontal line down to the cable. That is my angle of depression. It goes down from the horizontal that comes out of the top of the tower down to the cable. I need to find that angle of depression. One thing to remember about the angle of depression, it's a very important thing to remember, is that the angle of depression is equal to the angle of elevation. Okay, angle of depression is equal to the angle of elevation. So let's go ahead and find the angle of elevation. Angle of elevation goes up from the horizontal, which in this case is the ground. It goes up from the ground to the cable. Angle of depression goes down from the horizontal to the cable. Angle of elevation goes up from a horizontal to the cable. So this right here is the angle of elevation right there. And the angle of depression and the angle of elevation, they're equal. Okay, so if I find the angle of elevation, I've also found my angle of depression because they have the same measurement. So what I'm going to do, I'm going to find my angle of elevation. And that will also be my answer because it's equal to the angle of depression. Okay? So I'm actually going to find this angle right here. And next step, once we have our triangle, our triangle is right here. Our triangle, that's my right angle. Next step, go ahead and label the sides. So I'm working from this angle directly across from it. That right there is my opposite. I'm going to go ahead and label it OPP. This is my opposite. Directly across from my right angle, this side right here, that's my hypotenuse. I'm going to go ahead and label it HYP. And the only side that I have not labeled, that must be my adjacent. That's my adjacent right there. I'm going to write SOHCAHTOA. Go ahead and walk through it a little bit quicker because we did this in the last few problems. SOHCAHTOA kind of remind me what sine, cosine, and tangent are. And then I need to determine which one am I going to use, sine, cosine, or tangent. Am I going to use the SO, the CA, or the TOA? Well, I look at my triangle. I have this measurement, 30, which is the adjacent. So I have to use A. And I'm looking for, well, I also have this measurement right here, 50, which is the opposite. So I need to use the opposite and the adjacent. I have to use O and A because those are the two measurements I have. And I'm looking for an angle. So I have to use the O and the A. I have to use O, A. I have to use tangent. So I'm going to write that equation right over here. And I'm looking for the angle, which we will call X. So I have tangent of X equals, and I know that the tangent of X is going to equal the opposite, which is 50. It's going to equal 50. Tangent is opposite divided by adjacent, so it's going to be opposite divided by adjacent, which is 50 divided by 30. Okay, so we have that equation right there. Tan x equals 50 divided by 30. Well, I got to get this x by itself, so I got to get rid of that tangent. I have to do the opposite of tangent. The opposite of tangent is inverse tangent. Okay, so to get this x all by itself, I have to do the opposite of tangent, which is inverse tangent. And this looks like tan negative 1, that's inverse tangent of tan x equals, so I took the inverse tangent of this side, I also have to take the inverse tangent of this side. What I do to one side, I got to do to the other side. Okay, so to recap, I had to get that x all by itself, so I had to get rid of the tangent. I had to do the opposite of the tangent to get rid of it. Opposite of tangent is inverse tangent. What I do to one side, I have to do to the other side. Well, we just said inverse tangent gets rid of tangent, so it cancels out the tangent, leaving just the x on this side equals, and this is what I'm plugging into my calculator, inverse tangent 50 divided by 30. Okay, so that's what I'm going to type into Desmos to get my answer. It's already in degrees, so I do not have to check that. I hit functions. I should be under my trig functions, and I will see tan to the negative 1. I go ahead and select that. Tan negative 1, 50 divided by 30. Okay, and I get 59.036. That's going to be my angle. My angle is going to be 59. I'll go ahead and round it to 2 decimal places. 0, that 3 is going to go up to a 4 because the number after it's 5 or higher. 59.04 degrees. okay? That's going to be the angle I was looking for. Again, that's the angle of elevation. We had to find the angle of depression, but the angle of elevation is equal to the angle of depression. So if I found the angle of elevation, I also found the angle of depression. So that is my answer, 59.04. Okay. From the top of a lighthouse, 210 feet high, angle of depression of a boat is 27 degrees. From the distance, find the distance from the boat to the foot of the lighthouse. The lighthouse was built at sea level. Okay, so we read through the problem. Now we got to draw that picture. So again, first step, read your problem. Second step, draw your picture so we can find that triangle. From the top of a lighthouse, 210 feet high. So I'm going to draw a lighthouse. My lighthouse. This lighthouse is 210 feet high. It says the angle of depression of a boat is 27 degrees. So let me go ahead and draw my boat, and then I'll do the angle of depression. So I have a boat that's out here away from the lighthouse. Okay, so I have a boat. Angle of depression of a boat is 27 degrees. So the angle of depression is that angle. Let me just read through it again. The angle of depression of a boat is 27 degrees. Okay, so the angle of depression is going to be the angle that goes down from the horizontal. So I'm going to draw a horizontal that comes out of the top of my lighthouse. So imagine somebody's looking out straight ahead. Apologize, that was the bell ringing. Imagine somebody's at the top of the lighthouse and they look straight ahead. That's my horizontal. And then they look down at the boat. So this is their line of sight as they look down at the boat. Angle of depression is that angle that goes from the horizontal to the new line of sight that's looking down at the boat. So that is my angle of depression, and it is 27 degrees. 27 degrees. We need to find the distance from the boat to the foot of the lighthouse. The foot of the lighthouse, that's the bottom of the lighthouse. So I have to find the distance from the boat to the bottom of the lighthouse. So I have to find this distance right here. Okay, I have to find that distance right there. From the boat to the foot of the lighthouse. So there's my triangle. I have this. I'll go ahead and kind of draw it in there. I have this side right there. That's the line of sight looking at the boat. I have from the boat to the lighthouse. And I also have this right here. That's how tall the lighthouse is, 210 feet. Okay, and I'm looking for the distance from the boat to the lighthouse. I'm looking for this right here, which I will call X. Okay. Well, remember in my last problem, I said that the angle of depression is also equal to the angle of elevation. The angle of elevation goes from the horizontal up to this line of sight. Angle of depression went down from the horizontal to the line of sight. Angle of elevation goes up from the horizontal to the new line of sight. So this angle is also 27. Okay? So to recap, angle of elevation is equal to the angle of depression. And now I can solve this. So the next step is to label my sides of my triangle. Well, I'm working from this angle right here. Okay, I'm going to work from this angle that's inside the triangle. And I'm going to label my sides. Directly across this side right here, that's my opposite. I'll label it OPP. Here's my right angle. Directly across from it, this side right here, directly across from my right angle, this side is my hypotenuse, so I'll label it HYP. That's my hypotenuse. And the side I have not yet labeled, that's my adjacent. Okay. And now I can set up an equation and solve this. So I'm going to go ahead and put my SOHCAHTOA up here. SOHCAHTOA. That reminds me what sine, cosine, and tangent are. And I'm going to determine which one am I going to use. Am I going to use sine, cosine, or tangent? Well, I'm given this measurement, 210 feet, so I have to use that. Whatever measurement I'm given, I have to use it. So I have to use the opposite. I have to use the O. And I'm looking for this, which is the adjacent, so A. I have to use O and A. Well, if I look here, it's not SO because that's O and H. It's not CA because that's A and H. It's going to be this TOA because that is O and A, opposite and adjacent. So I'm going to use tangent. Okay, so I'm going to set up my equation over here. I have tan, following the tangent is always going to be my angle. So tan 27 equals the opposite, which is 210, divided by the adjacent, which is x, because I don't know what it is. That's what I'm trying to find, x. Okay, so tangent equals opposite over adjacent. Tangent equals opposite, which is 210, over adjacent, which is x. That's where that comes from. Tangent 27 equals 210 divided by x. Well, in the last problem, we said that if your x is in the bottom of a fraction, you can move it up here, and then you can move this tan 27 down to where the x is. These two things can switch places. So that's what I'm going to do. I'm going to put the x where the tan 27 is. I'm going to put that tangent 27 down to where the x is. Okay? And that's what I'm going to type into my calculator. So I'm going to pull up Desmos real quick. And I'm going to go ahead and type that in there. So I have 210 divided by, hit my functions, find my tangent, and I have 27. Okay. I get 412.14. That is how far the boat is away from the lighthouse. It is 412.148 feet. I'll go ahead and round that 4 to a 5 feet. Okay? So that is the distance of the boat to the lighthouse. 412.15 feet. Okay, so that concludes our lesson on trig applications.